In the domain of science and monumental mysteries, the question of what preceded the enormous explosion has sparked discussions and intrigued minds for quite some time. This vast inquiry not only tests how we might decipher the cosmos, it challenges the very boundaries of human comprehension. Picture yourself standing at the brink of existence, peering into the vast unknown, pondering what might have been there before our universe took shape. The event of the Big Bang signified the commencement of time, space, and everything we understand. But was there a moment before this? Could there have been a state of void, a stillness before the cosmic event unfolded? And if this is accurate, was it, or could it have been something even more extraordinary that existed prior to time itself? As we delve deeper into this inquiry, science takes us on a journey beyond the universe's origin into concepts that challenge our awareness. Physicist Brian Cox, renowned for his exploration of the marvels of the universe, proposes that something remarkable may have existed before the immense explosion. He encourages us to reconsider our notions of reality and existence. In this exploration, we'll dissect the science, the hypothesis, and the captivating secrets that may shed light on what occurred before it all. We'll examine ideas like self-started evolution, quantum shifts, dark energy, and even multiple universes. The discoveries we've made might astound you, but they could also unveil new insights into our role in the cosmos. Prepare to dive into a realm beyond imagination and science, where the unexplained still hides in the shadows, leaving scientists astonished and sometimes even confounded. Let's investigate what existed before the Big Bang and why these theories challenge everything we believed we knew. To grasp what might have existed prior to the Big Bang, we must first carefully examine what the Big Bang truly was. The Big Bang, as scientists define it, refers to the moment when the universe became incredibly hot and dense, expanding rapidly to initiate the creation of all matter, energy, and fundamental forces. When we gaze up at the night sky, we see evidence of this fiery beginning, with galaxies moving away from an early central point. But why did this occur, and was there a time before this intense hot origin? According to the theory of immense expansion, there was indeed a preceding state, and it was far from vacant or tranquil. Cosmic inflation suggests that before the Big Bang, the universe was in a condition that was cold, empty, and loose, almost like a colossal vacuum. However, this vacuum was not completely devoid of substance. It contained a tremendous amount of energy that fueled the swift expansion of space itself. This expansion, referred to as inflation, happened so rapidly that it essentially laid the groundwork for everything that followed. Space stretched at unimaginable speeds until the expansion slowed, and the energy transformed into matter, particles, and the forces we now observe as the Big Bang. But what was the nature of this energy? Why did it suddenly cause the universe to expand, and why did it? See, scientists suggested that this cosmic inflation resulted in pockets within the universe, each experiencing its own Big Bang. Imagine fabric stretching endlessly with tiny bubbles forming here and there, each bubble representing a universe including our own. This concept, called the inflationary multiverse, implies that there might be an infinite number of Big Bangs and innumerable universes. Ours is just one among many. This vast, mind-bending reality challenges our understanding of the cosmos and leaves us contemplating what else might exist beyond it. The idea of nothingness before the Big Bang is hypothetical, but not entirely beyond possibility according to our current knowledge. Even if you were to remove all energy, particles, and radiation from the universe, it still wouldn't be truly void. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that weave a complex fabric of something even in its most barren form. Even if we imagine stripping away all of these forces, leaving an empty space, the universe would still generate new forms of energy. This fact alone puzzles experts, as it suggests that true nothingness might be unattainable within our infinite understanding. Space itself has qualities, rules, and constants that prevent it from being completely empty of matter. Imagine creating a region with absolutely nothing in it, no particles, no radiation, and no energy except for quantum fields and fundamental constants. These would still remain, indicating that this nothingness has specific properties. For example, there is a concept known as zero-point energy, which represents the lowest energy state of quantum fields. In this state, particles can still briefly appear and vanish, creating a phantom rhythm of activity even in what should be empty space. This challenges our notion of a genuine void and implies that even before the Big Bang there may have been something that scientists are only beginning to understand. One of the most astonishing ideas in contemporary cosmology is the possibility of eternal expansion. If inflation could cause our universe to exist, it's conceivable that it could continue indefinitely. Brian Cox describes an exceptionally vast inflationary multiverse where universes are ceaselessly created and continue to expand. Imagine each Big Bang as a spark igniting another universe, while inflation persists in other regions, generating countless additional universes. This process could, in theory, last forever. This notion of infinite universes gives rise to a captivating idea of a fractal universe where each new universe might essentially generate its own Big Bang. Every universe would exist as a separate, independent domain, untouched by the others due to the rapid expansion of space. For theorists, this hypothesis is both exciting and unsettling, as it suggests a never-ending multiverse with no distinct beginning or end. Picture our universe as merely one fragment in a massive cosmic structure, eternally expanding and continually producing new universes. And what if the unsettling truth is that there is no before or after, but instead an eternal cycle of universes emerging and decaying? Our interpretation of nothingness shifts when we consider quantum field theory. According to this theory, the universe is not simply a collection of matter suspended in space. It is a complex network of energy fields that permeate the cosmos, interconnecting to form everything we observe. These fields resemble invisible oceans with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they remain active. Particles can spontaneously appear and disappear within these fields, briefly gaining energy before returning it. This phenomenon produces virtual particles, entities that briefly exist and then vanish, leaving only a faint trace of their presence. The concept of virtual particles challenges the idea of a true void. Imagine an empty cosmos where all matter, radiation, and energy have been removed. Would you have complete nothingness? According to quantum field theory, you would not. Even in a vacuum, fields would persist, sometimes generating fleeting particles. This continuous movement in what should be void suggests that the universe does not conform to our idea of emptiness. The fields and forces persist, filling the cosmos with hidden energy that prevents true nothingness. This realization raises an intriguing question. If fields create particles and particles create matter, could the universe itself have arisen from this nothingness infused with quantum fields? Dark energy is a perplexing force that currently drives the accelerated expansion of our universe. But did dark energy exist before the Big Bang? From certain viewpoints, the very existence of dark Energy today may be a remnant of an energy field from before our universe's formation. The properties of dark energy seem to suggest an immense hidden force that may have existed in some form prior to the Big Bang. Some hypotheses use that dark energy in a more potent state could have governed the inflationary period, causing rapid expansion. The presence of dark energy implies that even if our universe were drained of all matter and radiation, this force would still stretch the fabric of spacetime. This thought leads to a troubling question. If dark energy existed before the Big Bang, might it have been the force that initiated the creation of our universe? Could dark energy be the silent architect of inflation, or perhaps the true origin of our universe? As we explore this possibility, we face the potential of dark energy not just as a force shaping our universe, but as the key that could unlock the mysteries of the multiverse itself. Another theory that offers an alternative to the Big Bang as the ultimate origin is cyclic cosmology, the idea that the universe undergoes endless cycles of birth, death, and rebirth. In this model, the Big Bang is not a singular event but part of a timeless rhythm where universes expand, contract, and then regenerate in another cycle. This theory proposes that our universe may have been reborn from the remnants of a previous universe. The process of contraction and expansion in a cyclical pattern would imply that there was never a true beginning, but rather an eternal series of universes being born, growing, and renewing themselves repeatedly. Cyclic cosmology raises profound questions about time, as it suggests that time itself may be cyclical rather than linear. If this hypothesis is accurate, it could mean that what existed before the Big Bang was simply another version of the universe, one that collapsed only to give rise to our current cosmos. For theorists, this model offers a compelling answer to the question of ultimate origins, proposing that there is no true beginning. The universe has always existed in some form, transcending our understanding of time and existence. Primordial gravitational waves are another fascinating concept that could offer insights into what existed before. For the Big Bang, gravitational waves are ripples in spacetime caused by massive cosmic events, and scientists believe that early-stage waves, if detected, could reveal clues about the universe's earliest moments. These waves could serve as echoes of what came before the Big Bang. If identified, they might provide evidence of the universe's previous conditions and show that the cosmos has undergone multiple phases of expansion. Gravitational waves are crucial for understanding the true nature of spacetime and could hold the key to unlocking what occurred before the Big Bang. However, technology is still catching up to the task of interpreting these waves, and much work remains before we can fully understand their significance. As we await further advancements, the universe may prove to be far older, far more intricate, and full of unseen processes that remain beyond our comprehension. Gravitational waves could reveal the secrets of this deeper reality. The theory of what existed before the Big Bang is a journey fueled by curiosity and speculation, with ideas like quantum fields, cyclic cosmology, and dark energy. Our understanding of the cosmos continues to evolve. While we may never have a definitive answer to the question of what existed before the Big Bang, this ongoing exploration brings us closer to unraveling the profound mysteries of space and time. The exploration of what occurred before the Big Bang also opens up philosophical questions about the nature of existence itself. If we consider the possibility that the universe has always existed in one form or another, what does that mean for our understanding of the beginning and the end of time? Do we need to abandon our traditional view of a singular creation event and accept that the cosmos is part of an eternal cycle, or perhaps an infinite sequence of births and deaths. Such concepts stretch our imagination to its limits and challenge the fundamental nature of time, space, and reality. Many theories, such as those of quantum gravity and string theory, suggest that the universe may exist within a larger, more complex framework than we can currently perceive. For instance, string theory posits that the very fabric of the cosmos is made up of tiny vibrating strings that are too small to be observed directly but influence the fundamental forces of the universe. If this theory holds any truth, the origins of the universe and what existed before it may be deeply tied to these fundamental strings, offering a new perspective on the birth of the cosmos. One particularly fascinating concept in the context of quantum gravity is the no-boundary proposal put forward by physicist Stephen Hawking. This theory suggests that the universe does not have a singular beginning in the traditional sense, but rather it exists in a way that eliminates the need for a defined point of origin. According to this idea, the universe may have emerged from a quantum fluctuation where the concept of time itself becomes irrelevant at the very beginning of the universe. This would mean that asking what happened before the Big Bang is in a sense a meaningless question, as time itself may not have existed prior to the Big Bang. Another intriguing idea is the concept of parallel universes, which has gained popularity in both theoretical physics and science fiction. According to this hypothesis, the Big Bang might have occurred as a result of a collision between different universes, or the merging of multiple realities. If this theory holds, it would mean that our universe is just one of many that coexist within a larger multiverse, each with own distinct laws of physics and origins. This perspective introduces an exciting new dimension to our understanding of the cosmos and what came before the Big Bang, implying that our universe may have been shaped not only by its own history but also by interactions with other universes. Furthermore, the idea that the multiverse may be infinite raises the possibility that there is no ultimate before the Big Bang, as the multiverse itself may be endlessly self-generating. If each universe within this multiverse is constantly being created, destroyed, and reborn in an ongoing process of expansion and contraction, then the origin of our universe may not be an isolated event but part of an infinite, ever-evolving cycle. In this context, the Big Bang becomes just one chapter in the endless story of the multiverse. While these ideas may seem speculative, they are grounded in serious scientific inquiry, and many physicists are actively exploring them to better understand the nature of reality. The discovery of new phenomena such as gravitational W waves or the detection of cosmic background radiation might provide further evidence to support or challenge these theories.